In this video, we're going to learn about coinciding lines. But before we get too far into that, I want to revisit the topic of parallel vectors because it's going to lead us into how to tell if two lines are coinciding. So, as a reminder, to figure out if two vectors are parallel, you're going to start by seeing if they're scalar multiples of each other. So, if you would multiply vector v by a constant c to get vector u, then they are parallel vectors. And they might look something like this if they start at the same point. Now, when they start at the same point, you'll see that they actually overlap, and that is where the word coinciding comes in. They are over top of one another. Now, let's see if we can identify if two vectors are parallel. If I gave you u equals -3, -4, and v equals -9, -12, how could I tell if they were parallel vectors? Well, what I'm going to do is I'm going to pull the GCF out of each component for each vector. So with u, I can pull out a -1 from both of my components, and it becomes -1 times 3, 4. V, I can pull out a -3, and when I do that, I get -3 times 3, 4. Now we can see they're both scalar multiples of the vector 3, 4, so they are indeed parallel. Let's try another one with vectors. Let's say I gave you u equals 18, 12, and v equals 10, -20. The greatest common factor for u is going to be 6, and it's times 3, 2. The greatest common factor for v is 10, and it's going to be times 1, -2. You can see that their base vectors do not match, therefore these vectors are not parallel. Now, as a reminder, this video is not actually about parallel vectors, it's about coinciding lines. So how do we use what we just talked about to determine if two lines are coinciding? Well, you're going to have two formulas here, okay? So you have an equation for your first line, which is a1x plus b1y equals c1. And then you'll have an equation for your second line, a2x plus b2y equals c2. So they're exactly the same. We just have to make sure that we see that there's a different coefficients, all right? Now, if these two lines are coinciding, then a1 is a multiple of a2, b1 is a multiple of b2, and c1 is a multiple of c2. In all of these cases, k will be the same, all right? So let's take the strategy we used to determine if two vectors were parallel in order to determine if these two lines coincide. 2x plus 8y equals 10 and 3x plus 12y equals 15. I'm going to pull out the GCF from each equation. So when I look at 2x plus 8y equals 10, I can pull a 2 out of all of that, and that would be times x plus 4y equals 5. In my second equation, I can pull a 3 out of everything. When I pull out a 3 from everything, I get x plus 4y equals 5. Look at that. They're both multiples of the same equation. So in this case, we would consider our k value for the first equation to be 2 and our multiple for the second equation to be 3. All right? So yes, the lines coincide because they have the same equation as their base. Let's take a look at one more example. What if I gave you -3x plus y equals 4 and 6x minus 2y equals 12? Well, when I'm looking at that first equation, I'm going to pull a -1 out of all three really things. Okay, so it's -1 times 3x minus y equals -4. I like to pull out the negative just as a note because I want my first term, my x, to be positive. It makes it easier if I just go ahead and make that the rule, okay? So I want to make the first term positive in my second equation too, even when I pull out my GCF. So I'm going to pull out a +2. That leaves me with 3x minus y equals 6. All right, so these two equations, these base equations, if you will, look pretty similar. However, one is 3x minus y equals -4, and the other one is 3x minus y equals 6. So are they really the same, even though they look the same? No. So the lines do not coincide. And that's how you use our parallel vector information to figure out if lines are coinciding.